So this isn't really going to seem like implicit differentiation, but it's in this section. So what we're going to do is find some derivatives of radical functions by first rewriting them with exponents. So if I rewrite this square root as x to the 1/2 power, then I can just do the derivative using the power rule. So multiply by my exponent of 1/2 and decrease my exponent by 1. I'm just going to flip that x to the negative 1/2 to the denominator. And then your final derivative is just 1 over 2x to the 1/2. So how about a more complicated one? So this time I'm going to do the same thing with my radical. So I'm going to rewrite my square root as that quantity raised to the 1/2 power. This time I'll have to use a little chain rule, so multiply by my exponent of 1/2, leave the inside of my function the same, decrease my exponent, and then multiply by the derivative of the inside, which is 10x plus 3. Since I do have a negative 1/2 on my exponent there, I'm going to make this into, just left on top, 10x plus 3, and then my 2 and my 5x squared plus 3x minus 4 to the 1/2 go in the denominator. This one's already written with an exponent instead of a radical, but I would prefer not to use the quotient rule, so I'm going to rewrite it with a negative exponent. And then if I take my derivative, all I'm going to have to do is take and multiply my 2 by my exponent of negative 3/4, decrease my exponent by 1 to negative 7/4, and then multiply by the derivative of the inside, which is going to be 2. If I take and multiply those constants together, I'm going to have just plain old negative 3, and then pop that 2x plus 1 to the 7/4 to the denominator, and we should be good. Let's take a look at one of your favorite trig function derivatives. So chain rule here means I'm going to have to work from the outside in. So to start with, let's take care of that exponent of negative 2/3 by multiplying by it. And then I'm going to leave everything inside the same. And then I'm going to decrease my exponent to negative 5/3. And then working towards the inside, I'm going to multiply by the derivative of cotangent, which is negative cosecant squared, still with my angle of 3w. And then the very inside, the derivative of my angle is going to be 3. So if I multiply a few things together here, my negative 2/3 times my negative 3 cosecant squared, I'm just going to end up with that expression right there when I am all said and done. I hope you are ready for a messy one. So this is going to take some product rule. So I'm going to go ahead and do the derivative of my first expression that's underlined in orange. And that's going to give me that result there. Have to use some chain rule. Leaving my second one as it is. And then the other half of my product rule, my original first function, x squared minus 2 to the 2/3 times the derivative. So I'm going to multiply by my exponent of 3/5, leave the inside the same, decrease my exponent by 1, and then multiply by the derivative of the inside, which is 5. Now if you look, I have some common factors. They both have a group of x squared minus 2. What I'm going to factor out is like the smaller amount of factors, which is my negative 1/3 power, because negative 1/3 is less than positive 2/3. I'm also going to factor out a 5x minus 1 to the negative 2/5, because again, that's my smaller exponent. And then what that's going to leave me with is my 2/3 times 2x. And then if I subtract my exponents on my 5x minus 1, 3/5 minus negative 2/5 just makes that to the first power. And then same idea on my next one. If I take 2/3 minus negative 1/3, I just get an x squared minus 2 to the first power. And then I'm going to go ahead and take my constants and multiply them together. So like my 2/3 times my 2x will be 4/3 x. And then my 3/5 times my 5 is going to just get me a 3 times the quantity x squared minus 2. And everything that I had factored out has negative exponents, so I'm going to go ahead and move those to the denominator. I just rewrote it because it looked like they were missing, but I'm going to move those to the denominator. So it looks like this. Now on top, I still have a fraction involved, and I don't really want a fraction within my fraction. So instead of like getting a common denominator between the terms on top, I'm actually just going to multiply this whole thing top and bottom by 3/1. So if I do that, 3/1 times 4/3 just makes that 4 times my x in my first quantity. And then distributing to my second group, I'll have a 9. And then in my denominator, I'll have 3 times all those. So that's kind of a good strategy for getting rid of fractions within fractions. I'm going to distribute my 4x and my 9 on top, and then combine some like terms. And then finally, we should be all said and done with this problem. I know it's kind of a long one. So when you put things together, you get 29x squared minus 4x minus 18 all over my 3 times x squared minus 2 to the 1/3 times 5x minus 1 to the 2/5.